Today is Tuesday, May 9th, and we are working on Chapter 9, the chapter review of Chapter 9 on inequalities. And the first 6 questions we have here are your definitions, your vocabulary. A mathematical statement comparing expressions that may not be equivalent, I should say may or may not, but that's better, is called an inequality. Inequality. Inequalities can be represented blank on a number line or blank using symbols. Graphically on a number line or algebraically using symbols. On a number line, a blank blank indicates the boundary point is not a possible solution. That's an open boundary or an open point. In this equality, x is greater than 5. The value of 7 is a specific solution. And on a number line, the value that separates solutions from non-solutions, where do we put that? Is called a boundary point. And finally, on a number line, a blank blank indicates the boundary point is, that's the big word there, that's a closed boundary or a closed point. An internet business is preparing a flyer to advertise a sale, express each statement as an inequality. A savings of up to 40%. So the percent you can save can be less than or equal to 40%. That would be your inequality. Free shipping on $500 or more. So the shipping is free if you spend greater than or equal to $500. And over 80 major items, not 80, but over 80. So items is greater than 80 would be a good algebraic inequality. Question 8, road racers use bicycles that are designed to go as fast as possible. Cycling organizations place restrictions on bicycle design to ensure fairness and rider safety. Express each restriction as an inequality. The minimum allowable road racing bicycle mass. So the mass, the minimum, you have to be greater than or equal to 6.8 kilograms. That's the minimum. It has to be at least that. A road racing bicycle can be no more than 185 in length. So the length must be less than or equal to, but algebraic L, 185. The length of the bike must be less than or equal to 185 centimeters. Question 9 says verbally and algebraically represent the inequality. So for A, it is 13. So all values greater than 13, but not equal to. All values greater than, but not equal to 13. And I would say all numbers greater than 13. And there's other ways to do it, but that's why I'm going to write it. B, this is 9, 8, 8.2, 8.4, 8.6, 8.8, 9. So 8.6, all values, I'll use x this time, all values less than or equal to 8.6, or all numbers less than or equal to 8.6. Question 10 says sketch a number line to represent the inequality. All values greater than -4. So when you do these on your test, always start with your number that you know in the middle. If it's negative, make sure you set it up properly with the negatives in the right positions. All values less than -4, because it's not equal to, it's an open boundary point. And less than -4 would go that way. With B, all values less than or equal to 7. 7 goes here, 6 goes there, 8 goes there. I'll use a different color. All values less than or equal to 7 means my number goes that way. For question C, now remember when you have it this way, read it backwards, all values less than 9.5. So here, if I put 9.5 in the middle, it would be smart if you went 9 and 10 here. Show some muxy. All values less than 9.5, not including it, open boundary. Shuffle that over to the other direction. And our last one, D, all values less than or equal to negative 5/4 or negative 1 1/4 if you wanted to change it. It's the exact same thing, probably easier if you did it that way. Negative 1 1/4, negative 1, negative 1.5 would be good boundary points there going up by quarters. You can do whatever you want though, it doesn't matter. And all values less than or equal to, meaning closed boundary point. And that way. All of our arrows went that way, didn't it? Interesting. Not one of my Grateful Dead heads realized that I actually made a mistake. Didn't I? All values greater than -4 would go that way. My groups did not pick up on that. They are all... If only you could see this through YouTube videos, you would be able to see 21 completely tired and not very bright looking students. Except for Carl. Carl always looks intelligent. Question 11 says, for number 10, state one value that is a non-solution. So for a non-solution, or a number that is not for the first one, -5 is a non-solution. And for a solution, -3 is. For here, a non-solution would be 8, and a solution would be 6. A non-solution, or a number that does not exist in the set of numbers that's valid, is 10, and the solution is 9. And over here, a non-solution would be -1, and a solution would be -1.5. Question 12 gives us solving each inequality, which is a piece of cake. So for the first one, d minus 7 is greater than -2, or -10. We're going to solve it by using our algebra sense. All values greater than -3 is your solution. B, add 2.7 to both sides. 5.4 is less than 8. Now on your test, you're probably going to be asked to not only write your solution like that, but also graph it, because I need to know that you know what it says. So -3 goes there, -4 goes there, -2 goes there. Open boundary point, all values greater than -3 would go that way. All values greater than 5.4. All values greater than 5.4, open boundary. Just like that. C, I'm going to multiply both sides by 3. And B will be any value less than or equal to -33. I didn't flip my sign because I multiplied by a positive value. In your number line, -33, -34, -32. All values greater than or equal to, less than or equal to, -33. And finally, your last one, D, is -1/5 C. Now remember, 1/5 C is the same thing as this, right? That's a fifth of C. So what I would do right off the bat is I'd be like, I'm not writing that. And I remember Mr. McDonald told me a long time ago that if this was negative, you could write it like this, you could write it like this, or you could write it like this. For the purposes of algebra, it's always best to write it with the negative sign in your denominator. I'll show you why in a second. So I'm going to write it as this. That is a -5 of C is greater than 3.2. Now there's a reason for that. Because to isolate, I'm going to multiply both sides by -5. And when I multiply or divide by a negative number, Dawson, what should you do? Yes, you should. You get C and you flip your sign, -16. So all values less than -16 on the number line. Open boundary, because it doesn't include it, and any value less than that will work.